The facade is considered to be the face of the building as it is the first thing a person notices about a structure. But at the same time, when you think of it, it is also a kind of skin that links the insides of the building to the outer environment. And because of this, energy efficient aspects need to be implemented in the facade technologies. In the International Energy Outlook 2017, we can see that there is an expected increase of 2.7% per year in the energy consumption for residential and commercial buildings in India between the years of 2015 and 2040. The introduction of interactive facades can help reduce this consumption by about 20%. Thus, it is crucial and essential to come up with facades that provide the occupants with the best comfort without too much energy consumption. That is the reason this paper is investigating different kinds of facades to promote their use in building design according to the climatic zones they are in. The study of ancient types of facade treatment and how it evolved into the new forms will let us make better use of the facade in more effective ways. The major central research question that my paper focuses on is how different types of facades can reduce energy consumption, and the sub-research questions being, what are the qualities that make a building energy efficient? And what are the ancient facade treatments practiced in India, and what are the modern facade treatments that are being used now? The facade is considered to be the face of the building as it is the first thing a person notices about a structure. But at the same time, when you think of it, it is also a kind of skin that links the insides of the building to the outer environment. And because of this, energy efficient aspects need to be implemented in the facade technologies. In the International Energy Outlook 2017, we can see that there is an expected increase of 2.7% per year in the energy consumption for residential and commercial buildings in India between the years of 2015 and 2040. The introduction of interactive facades can help reduce this consumption by about 20%. Thus, it is crucial and essential to come up with facades that provide the occupants with the best comfort without too much energy consumption. That is the reason this paper is investigating different kinds of facades to promote their use in building design according to the climatic zones they are in. The study of ancient types of facade treatment and how it evolved into the new forms will let us make better use of the facade in more effective ways. The main aim of my research paper is to understand different types of ancient and modern facade treatments used in our country and how they help in bringing down the energy consumption. The major objectives are to understand the idea of energy efficiency, to study about the ancient methods of facade treatments, and to process the evolution of these facade treatments over the time, and to finally analyze the modern facade treatments that are currently being used. The scope of my dissertation paper is to understand how facade treatments can lower the energy consumption in Indian climatic context and how they've evolved throughout different decades. Talking about the limitation, since India is a country with vast climatic conditions due to the different geographical landforms, this paper only covers certain parts of the country for comparative study. Similarly, since the facade treatments in both ancient and modern era are plenty, this paper only talks about 4 examples from both ancient and modern facade designs. And when we come to the significance of the paper, we can see that it is essential to control the carbon footprints of the emerging boom in the construction field with the huge increase in amount of buildings that are coming up. This paper can open up new effective ways to control the energy consumption of buildings by not compromising the comfort of the inhabitants through installation of facades that are responsive to the outside environment and acts as an intelligent element of the design. The facade is a very essential part of a building. When we look at the diagram, we can understand the functions of a facade. That is, to protect the building from the outside forces, that is the sound, the wind, the rain, and the direct sunlight. But this is just the basic functions. From the literature review, we can understand that it can be used to control the energy consumption of a building. Thus, incorporating interactive facades will allow the facade to interact with the outside environment and use these natural sources of energy in a positive way. A great deal of energy consumption can be brought down significantly by replacing passive environmental solutions in place of mechanical methods. There are so many ways to manipulate the functions of a facade. When we look at the first picture, we can see there is a maximization of daylight into the building, which will in turn reduce the dependence of the building on artificial lighting. This can be done using light wells, roof monitors, atriums, etc. On the next image, we can see the Jali work of Vishranti office in Chennai. Jalis are traditional elements of architecture used from a very long time ago. They let in natural light and ventilation into the building without compromising on the privacy factor. And then we can see overhangings being used near openings, which will reduce the heat gain during summers and bring in more heat during the colder seasons. When we look into the ancient facade treatments, we can see that they usually used the materials that were locally available. In southern parts of India like Kerala, wood and laterite were used for making double skin facades, but whereas in northern parts, more of an Indo-Islamic ornamental detailed facade treatments were seen, like in the picture, a Jaroka in Maheshwar Fort, Madhya Pradesh, which is an example of Indo-Islamic architecture. But in India, they used timber, as timber were available in plenty and they were very good insulators of heat. With the evolution in the field of facade treatments, more responsive facades like the kinetic facades came about. The introduction of glass brought about changes in the double skin facade treatments. Listed down in the table are type of intelligent facades and their main potential towards a sustainable design of low energy buildings. When we talk about kinetic facades, as we can see in the picture, they have temperature sensors on them which allow them to detect the changing weather and thus open the panel according to the need. This makes them an intelligent element as they respond to the changing environment outside to bring better comfort to the inhabitants. Down, we can see the working of a double skin facade with glass as medium. This is a form of modern treatment of facade. Firstly, I try to understand the definition of the term facade and how interactive facades are different from normal facades. Then, I try to find the link between energy efficiency in facades and how they can work as one. Since energy efficiency is a very vast topic, I limited my topic and brought light upon factors such as natural lighting and ventilation that can be altered and enhanced with the help of interactive facades. And similarly, since there are so many types of ancient and modern facades, I limited the examples to 3 from each. Further, by studying the examples of these different types of ancient as well as modern facades and how different forms of facades were found in different climatic zones of India, I understood more about this topic. And finally, I learned about the evolution and I tried to understand how the facade treatments evolved over the time. This was a methodology that I followed in my research paper. The initial data collection for my paper were done from books and other web resources. As the topic is very vast, the limitations were done regarding the number of examples taken for both ancient and modern facades. Due to the present scenario, I was not able to conduct any live case studies, and because of this, I did a comparative literature case study to understand how the ancient facades were different from the modern. As India is a country with a variety of climatic region, I chose 2 examples for comparative study that came from the same climatic region. As you can see in the Indian climatic zone map, I chose Kerala and Goa, which both come under tropical wet region. For the case studies, I chose Bank of India Sustainable Architecture Building in Goa and Padmanabhapuram Palace in Kerala. The Bank of India is a sustainable architecture building in Goa that is situated in Panaji. It opened up in the year of 2011. The most striking part of this building was its broad utilization of glass from both a practical and aesthetic perspective. This structure required a framework that would give it an ideal and cooling solution at the minimum expense. And because of this, glass was focused as it was found as a suitable arrangement with its capacity to loan itself for heat regulation. It helped in controlling the inside temperature efficiently and diminishing the dependence on power. It made the structure more sustainable. The Padmanabhapuram Palace is an extraordinary piece of wooden craftsmanship. Over 400 years old, it is an exceptional example of indigenous building technique. The palace structure is built out of wood with laterite stones. The external corridor acts as a double-skin facade with its wooden building envelope surrounding the main structure of the building. This double skin helps to reduce the heat gain. The exterior facade is done with wood and the wood won't retain the heat and hence it makes cooling effect inside the building. Similarly, as you can see in the picture below, this double skin also avoids the rooms from getting direct sunlight because of the wooden structure. And these wooden structure also gives a sense of security as the people outside does not have view to the insides of the building while the people inside have better view outside. From the collected data, we can surely say that the facade is indeed a crucial factor of a building. It forms the face of the building, it forms the identity of a structure, and because of this very reason, it was always given so much importance and the facades were done in very aesthetically pleasing manner. But our further studies show how facades are manipulated for better energy conservation. As from even older time, architecture tried to link the outside environment to the inside of the structure and thus build better comfortability. And for building better facades that respond to the climatic conditions, it is important to know the outside environment and changing weather before choosing a facade that reacts to it. So, for us to build a facade and do facade treatments that help in energy conservation, we need to know our environment. Only when a facade knows the changing weather conditions, we can make it respond to it. Thus, it is very important to know the different kinds of climatic zones of India. I have tried to classify them into 5 in the table below and chose 5 cities as examples to compare the comfort problems, dwelling spaces, building depth, building orientation, materials, and percentage of opening area. The 5 cities that I chose are Trivandrum, Nagpur, Ahmedabad, Jaisalmer, and Lucknow. The result indeed shows how our initial findings and research were fruitful and justified. The case studies show how 2 buildings in 2 different time periods but the same climatic region tackled the issue of energy conservation through facade treatments. It shows how facade can always be more than just an identity of a building to a very determining element of the structure. In the ancient times, there were use of locally available materials like wood for construction, while the modern methods used newer materials like glass for their treatments. But both the cases show how the issue of bringing down energy consumption by increasing the comfort of inhabitants were possible. The ancient facade had more privacy compared to the modern methods of using glass. So jalis and wooden shadings can be given to residential or such buildings where privacy is concerned. And the latter, modern techniques can be applied to commercial buildings as they require daylight to replace the dependence on artificial lighting. And also as commercial buildings do not require much of privacy compared to residential. Energy efficient intelligent building technologies, especially the facade design, play an important role for the proper and sparing use of energy. In the line with the latest advances in technology, intelligent buildings compatible with their environment can provide for highly efficient energy use. For designing intelligent facades, local climate conditions, outdoor environments, indoor spaces, energy performance, thermal comfort, indoor air quality, visual comfort, etc., are parameters that should be taken into account. Intelligent facades assist the designer to pass from the idea to architectural concept by using climate and visual comfort strategies that comply with an energy code.